Hi there. This is my third video in a series of lessons where I explain step by step how to build an integration solution based on the Azure Integration Services, where the logic app is the core component of the solution design. If you didn't see my first two videos, please find the links below in the description of the video. In these videos, I explain the solution, building it from scratch. And now in this part, I'm going to explain how to extend the solution. And I'm going to add a service bus, which is a pretty important component in every enterprise scale solution. The solution which I will build today looks like depicted on this diagram. I will place a service bus in between application management and the logic app. What I'm going to do also is to use the role-based authentication in connection to the service bus. To connect the service bus, we usually used SAS, which is a shared access signature. And essentially, this is a key which is used to generate security token. But today, I'm going to connect to Service Bus with use of role-based access and system-assigned managed identity for both API management. It sends data to Service Bus, and in Logic App, where the Logic App connects to Service Bus and listens to new messages in the queue or topic. So why are we using Service Bus in our solutions? Let's have a look at the diagram. A Service Bus uses two methods of delivery of messages. First is a message queue, which is for message delivery, first output. And this allows for decoupling of application components. Producer, which sends messages, and consumer, which receives messages, don't have to send and receive messages at the same time. Because producer and consumers aren't aware of each other, they can be upgraded independently. Here we say about decoupling. An additional benefit here is so-called load leveling, which allows for enabling of producer and consumers to send and receive messages at different rates. The receiver or the consumer of the messages only has to be able to handle average load instead of peak load. So sending of the messages varies during different periods of time. It may be not so active. Then this may be changed with the peak time when the sender sends massive messages into the queue. But the consumer don't have the need to react to these variations in the workload. And regardless of the depth of the queue grows and contracts, the receiver is set up to use an average workload of the system. Delivery of messages by the queue is also called a pattern of competing consumers. Several consumers may be connected to a message queue, and only one of them will process a message. The one eventually picks up the message, and the message will be processed only one time. Another model of delivery messages by the service bus is topic with subscriptions. Topics and subscriptions provide a one-to-many form of communication in publish and subscribe pattern. Here you see that a service bus topic has 3 subscriptions, and each subscription has a receiver. The difference with the message queue here is that each published message is made available to each subscription registered with a topic. Publisher sends a message to a topic, and one or more subscribers receive a copy of the message. Essentially, a subscription resembles a virtual queue that receives copies of the messages that are sent to the topic. Subscriptions support the same pattern described earlier in the section regarding queues, competing consumer, and decoupling, load leveling, and load balancing. Okay, then let's go to our Azure Resource Group and start by creating a new instance of Service Bus. Service Bus namespace, as we used CMS integration. I use 002, not Europe. Pricing tier. We have a number of pricing tiers to choose from. They provide different functionality, which results in limitations to message size and to some functions which are not available in a basic pricing tier, for instance. So I choose the standard, which gives us all for our solution. And go to next. We have a public access, tags, and create. Here we go. The service bus was created. Next, we have two options to create either queue or a topic. I'm going to go with topics, and this will affect our development of the solution, because in the future I'm going to show you how the topic is used with several subscriptions. So I go to creation of a topic. Service bus topic, customers. I don't choose any of these options. They are not important for my solution. By the way, enable duplicate detection. This allows for detecting duplicate messages so that the same message will not be processed several times. Created a topic. Next step, I have to create a subscription to the topic. Let's go here. I'm going to give a name. Service bus subscription. Customers. Maximum delivery count. This is number of deliveries which will be done by the service bus or by the subscription before the message is moved to a dead letter queue. And the dead letter queue is the one which accumulates all unprocessed messages. So here, auto delete after idle time. This is pretty standard. I leave it the default. Never auto delete. Forward messages to queue topic. This option allows for forwarding a message to another queue or topic, which is not our case. Enable sessions. The sessions, I'm not going to use them in this example, but is a good topic to discuss a bit further. Really helps in some hard integration scenarios. Enable the lettering on message expiration. Okay, let's leave it default. And then I create the subscription. That's good. Next step. In the previous video, I created application insights and log analytics namespace. Now I'm going to use them, and we'll go to settings of the service bus. In order to connect the service bus to log analytics, we choose diagnostic settings, add diagnostic settings. I usually, for simplicity, use the name of the Azure resource and append a prefix ds, which is diagnostic settings. I will enable all logs and audit, all metrics, and in the destination details, we have to choose send to log analytics workspace. In the list of available, we can choose the one which is used for this solution and click just save. Here it is. The service bus is connected to the log analytics namespace, which means that activity of the service bus will be collected by Azure Logs. And I will do the same for the logic app, and it's done just the same way. We go to diagnostic settings and diagnostic settings, yes, the name of resource, logs, all metrics, send to log analytics workspace, number 2, save. And the third element to attach to log analytics is our API management service. It will be done just the same way. Okay, all metrics. Here we are given an option to choose destination table between Azure Diagnostic and resource specific. Microsoft recommends choosing resource specific, which is essentially a separate table in the log service for this particular resource. We follow the recommendation of Microsoft, save. And it's created. Okay. The next step in our setup of the solution is to give permission to access service bus for the API management service. I go to the access control setup for the service bus, and in the role assignment, I'm going to give access to the application management service to the service bus. Click add role assignment. Here in the list of permissions, we have to give Azure Service Bus Data Sender permission to the application management service because it will send messages to our topic, the topic created in the service bus. Next, here we choose the managed identity. API management service. And I have to show the setting we did earlier. For the application management service, in order to create a managed identity. It was done here on the security and managed identities. Status controls creation of the managed identity is on. This is the status identity ID. As you probably know, the managed identity is created in Azure Active Directory under Enterprise Applications. So it shows us the API management service that we need. Oh, sorry, I've got the two, but I need only one. Select. Next. And here it is. We have given data sender permission for API management to this service bus. And we have to do just the same for our logic app. But the logic app receives messages, so we choose the service bus data receiver permission, managed identity, select, and the logic app. And here is only one logic app, which is not the one we need. So we go to our resource group and this logic app, identity, on, save, enabled. And we should go back a little bit, select member. Oh, still one. Okay, let's go further. Data receiver. Yes. And I have my logic app here. Select. Next. Create. Here is the logic app with a permission data receiver. This will allow us to establish connection from these resources to the service bus without using any security key. Okay, so the permissions are given, and the next step is to move to the application management service and make some changes in it in order to include the service bus into our integration workflow, which starts at the call of the API operation. If you remember, we have created an API which is called CMS with operation customer. I will make change, and I'm going to change the operation name to customer, the name, display name to the customer. The name cannot be changed, so please think twice when you create your operation in the API management, because this is not editable value afterwards. And here in policies, and by the way, I can remove this comment completely. This is not needed. In this set of policies, we will find that the backend is set to our logic app. But as we decided, the backend will become a service bus, and then service bus will send a message to logic app. So I will make changes into API management operation policies, and then in the logic app to get it connected to the service bus. Okay. So we will go here in the definition of the service bus. It has to be an HTTP endpoint. We need to click on the override in order to enter the value. The value will be taken from the service bus, and we will find it in the properties in here. We have to add HTTPS. Okay. Click Save. And now, when we go to the policies, I still need to remove it. To the policies, we will find the backend is set to the URL of our service bus. We have to add a couple of policies which will make use of the service identity, and they will be added after base tag. So these policies are used to fetch the security token from Azure Active Directory and put this security token into authorization HTTP header. So the first line gets the token and writes it into a variable, operation variable, MSI access token. And then this variable is used as a value for the authorization header. Next, we have to add rewrite URI policy, which is our topic name plus messages endpoint. And the last part, the last policy will be setting header broker properties. The HTTP header broker properties is used to send message properties to the service bus. And there are several properties which can be defined. I will use only 3 of them here, like message ID, like label, and content type. I use content type application JSON for my message. The message will be in JSON format. The value of the broker properties HTTP header is a JSON structure. So the JSON is produced from these three attributes. Okay, we are then ready. I save it. The API operation is ready now. We can check that the backend is set to the service bus endpoint. Next step in our setup is changes in the logic app. So I'm going to go to the logic app and open the designer. And here we'll find that the trigger which was used previously is the HTTP trigger, which I'm gonna change. I'm gonna replace with a connection to the service bus. I'm deleting this one and search for service bus. And here it is. Here in the list, we can find several triggers. I will try to explain which one we need and how they are used. When a message is received in a queue using autocomplete and the same using pick lock, we are not interested in the queue because we are using a topic. So the next one, when a message is received in a topic subscription, autocomplete and pick lock, one of them we should use. And autocomplete means that when a message of the service bus is processed, it will be automatically released by the trigger. Releasing a message means that it will go away from the queue or from the subscription so that it will not be available for processing anymore. The peak lock is a trigger which locks the message. The message is locked for the period of processing of the message. And then we have to also use in the end of the processing of the message, we have to use an action which will release deliberately this message from the subscription or from the queue just the same way. The others, they are called when one or more messages arrived in the queue, when one or more messages arrived in a topic. These are triggers which pick several messages from the queue or from the subscription, in contrary to the one I will be using now, which picks only one message. So the only difference is that when you choose a trigger which picks several messages, you have to implement a cycle which iterates all the accepted messages where the processing will be done in each iteration. So I choose this one, as I said. And this screen is to create a connection to the service bus. So I have to give a name to it first. Service bus, pretty simple. In the list of authentication types, you can see that a man can choose from access key, from Azure Integrated, and from Logic App Managed Identity. Access key is about SUS token. Azure Integrated is for the personal identity. And the Logic App Managed Identity is the one we are going to choose. And here I have to provide the endpoint namespace, as it says, namespace endpoint. Where I will find it, I have to go to the service bus, and in the shared access policies, we can choose the default one, created by default. And in one of the connection strings, you can find here primary connection string and secondary connection string, and both start with the endpoint. So we have to copy this part. And then I paste it in here. And this is enough because previously I have given permission to access the service bus for this logic app. So I click create. And the connection is created. And by the way, behind the scenes, if we switch to the resource group, we will find an item API connection which is called Service Bus. So this one was created as a result of my creation of a connection. All the connection attributes are stored in here. If you delete it, you will lose the connection to the service bus. Okay, next. Here we will choose that topic. It's given the real topic from the service bus because the connection is established. And then the subscription name. Then here we can choose to read messages either from the main queue or from the dead letter queue. We're not interested in the dead letter now. So we choose main. Here we define the frequency of polling of messages from the subscription in our case. And the point is that this trigger of the logic app works with the poll model. It plays an active role. It self-checks the messages in the service bus. And with setting these attributes to the polling interval, we make so that once per 3 minutes, the logic app will make a request to the service bus subscription, which we have chosen, and check if there are any new messages in there. And it will fetch one message. If there are several messages, next message will be picked after next 3 minutes. So you need to balance this frequency and expected number of messages. Like for instance, if there are many messages which are created in the queue and you have a long polling period, it may happen that you or your service will not be able to process all the messages in time. So it's possible to set, for instance, seconds and set it to 1. And this means that each second the trigger will get a message from a queue or will check if there are messages in the queue. But remember that each activation of the trigger is billable. So the owner of this subscription, of this Azure subscription, will pay for all the activations of this trigger. And not only trigger. If there are in the queue, the message will be picked and then processed, and all these activities, all these actions are also billed. So be careful, select the appropriate polling interval, frequency of checking the messages. And for my test, it's not so important. I can leave it to 3 minutes. It's okay. Some processes do not require often message processing, do not generate messages often. So like once a day or once per 12 hours, for example, it's totally acceptable. As I said, it depends. So I choose 3 minutes. And then there were values assigned to these attributes. Here in this compose action, I restructured the message received from external party and assign the values of the message received to these attributes. So because I removed the previous trigger, HTTP trigger, all these values disappeared and I have to reassign them again. Before I go into assigning attributes of the new message, I want to show you one thing. So I save this now, sorry, this won't work. So I will remove it. And just for testing, I'm going to create a valid JSON structure just to be able to save the logic app. The previous JSON structure I save aside. So No, it doesn't work. When I try to save the logic app, the error message says that I can't save it because the workflow with response action type should not have trigger with recurrence property defined. And this is about this type of the trigger, which I use here, and the response, which is used in here in the previous scenario, in the previous video, where this logic app returned the ID of the created customer, ID of the customer created in Cosmos database. But because this one is a trigger to the service bus, it means that the response will actually respond to the service bus, which is not acceptable. It doesn't work. So I need just remove this section. I delete it. And then I save. And then it's okay. And this logic app is ready for testing because I'm going to show you how the message received from the service bus looks like. I use Visual Studio Code to send request to our API operation. And this is the previous scenario. So I'm going to update the URL used by API operation. And this can be done from the test tab from here. And then I go back to the Visual Studio Code. And for those who look this video without looking the previous ones, I use the Thunder client, which gives me functionality similar to the Postman. So I can call API right from the Visual Studio Code. And I'm going to send. And OK. I've got an access denied error, which was expected. It says that access denied due to invalid subscription key. The subscription key is sent in the OCP API subscription key HTTP header. And this value was used for another instance of API management. So I have to take the right one. And the right one, for simplicity, it can be taken again from the test pane. This is, but actually the subscription key is stored in the subscriptions, and this one can be taken from here. So I choose the option to show or hide keys, and then just copy this, and then move this value, paste it into the header, and I send the request again. Good. The status code 201, which is created, and this means that API operation accepted the request, and we have to go to the logic app, and we find the failed operation in here, which is also expected, but I wanted to show you what the logic app has received from the service bus. In the body, here came the message from the service bus subscription. And the message itself, which was sent from the Visual Studio Code, lays in the content data attribute encoded with base64. And here you will find also some attributes along with the message ID and the label, and by the way, the content type. These attributes assigned by the API operation policy. I go back to show you that these attributes were assigned by the policy. Okay, then in order to process the message, we have to take this value, decode it from base64 code, and then operate with this message. So what I do, I have to return to the designer, And before composing a message, I have to insert another action which parses our payload sent to the API operation. This is done by the data operations action, which is called parse JSON. And here I have to use the function called decode base 64. I prepare the call of it. And then I take content. And as you see, the content is the content data attribute value. I would also rename parse content. And here I need to use the message schema. And the message schema can be taken from what we have sent. Let's go to the Visual Studio Code, take this message, go back, and here I use a sample payload to generate schema. Okay, done. Then the decoded string will be parsed to this JSON schema, and then I will use the results of this parsing. I paste the original message, which is used for storing in the Cosmos DB database. Then we are able to assign the values which we want. Here from the parse content, these are CT, the postcode is this one, the street is address 9, oh sorry, too much, this. External ID is the ID sent with the request. The new ID, the one which is used in the Cosmos DB database, is assigned here by generating of good, a new good. Then I need a name, and this is contact person. Oh, sorry, the name of the customer name. And here is the contact person and the contact person phone. Okay. And don't forget to check this one. To Cosmos DB, we will send the results of the composing of the message. Good. Good. And I'm gonna repeat my test. I will change the number 15 and I send the request again 201. Good. Then I will go to the service bus and go to topic and to the subscription eventually. The statistic here says there is one active message in the subscription, which means that the message is not yet processed. And it's not processed. We will check if it's not processed. Yes, since the last error, which occurred that time, we don't have anything. It's not processed because, as I mentioned, this trigger works once per 3 minutes. And we have to either wait when these 3 minutes expire, or I can run the trigger manually, which I choose now. Successfully checked that trigger. Then I go and check the results of the last run. We've got the new run. And now, again, the content, which was parsed from, which was decoded first from base 64 and then parsed according to the given schema. So we've got this result here. Great. And then I decompose this message to build up a new structure like this. And then this new object is sent to the Cosmos DB database. And the Cosmos DB responded with a sent data plus some attributes assigned. But we are interested in this ID because I'm going to go to the Cosmos DB database now and check if this object is created. I go to Cosmos DB, then to Data Explorer, and in the Data Explorer I open the database, which is CMS, and the container, customer, and go to items. It shows me the list of items existing in the database, but I need a particular one. This ID, I copy it, and then with editing filter, I choose the where clause, and CID is the one I need, but instead of this value, I paste here the ID, apply filter, and this is the selection, and the object, which was created as with external ID ABC015. And I'm gonna go to Visual Studio Code to make sure that the ID ABC015 was sent. So we're back to the solution diagram. So the goal of my demonstration today was to show how we can receive the request of the client by the API operation with use of managed identity to connect the service bus and send this data to service bus topic. Then with use of logic app and its managed identity, connect to the service bus subscription and fetch this data from the subscription. Then restructure this data and save it into the Cosmos database. This works fine. And the next time, in the next video, I'm going to show how the Azure function can be inserted between the logic app and the service bus so that the Azure function uses its own trigger to fetch the message and then oversend it to the logic app. Can we need to use an Azure function? What benefit does it give us? The benefit is that the service bus trigger of Azure function uses the push model, so it doesn't pull data from the service bus. It gets the data immediately when the message appears in the queue or subscription. So with use of Azure function, we get a benefit of reacting to messages in the queue as quickly as possible. And then we avoid this negative effect of the logic app trigger with its pull model, where we have to admit that the pull trigger is constantly activated with a given frequency. Use of Azure function will give a benefit of saving expenses for the solution. The customer will not pay for unneeded activation of the trigger. And also the Azure function will allow us to build a solution which reacts more rapidly to the messages produced by the client. Thanks if you saw the video up to the end, and please set like if you find it interesting, and see you next time with development of the integration solution. Goodbye.